They don't call switching power supplies voltage to smoke converters for nothing. Because when they fail, they can fail catastrophically. And in this case, that's exactly what happened. No, there's not one capacitor or two capacitors that are blown. No, there's not. Try for 6. Try for a resistor that has been turned to ash and a zener diode popped and a bunch of connections on the board that are shot. This one was a real mess. This time I've got another Samsung SV5000. This one was brought in today and apparently it's totally dead. Let's plug it in and verify that it is completely dead. The fellow that brought me this one had a little story to tell me. So we were talking about the time of day billing for our electric here, because he has a server and it runs 24 hours a day. So for him, switching to time of day billing will of course save him 3 hours of the rate will be reduced for 3 hours a day, because it goes up for 5 hours but it goes down for 8. So the net savings for him would be 5 cents a kilowatt hour for 3 cents, or for 3 hours every day, which means a little bit of a savings, especially since he has set his server sits and draws, I think he said it draws about 1,000 watts or so 24 hours a day. So that's like leaving a toaster plugged in. Pop the front off this. Anyway, we're talking about power consumption and stuff, and he told me that he started having the breaker started tripping on his server. You know, he lost power, so he reset it and he rebooted everything and it tripped the breaker again. He reset it and rebooted everything and it tripped the breaker again. And then he figured out what had happened was somebody had hacked into his server and was using his server to mine Bitcoin. And of course the power consumption went from 1,000 watts to over 1,500 and was tripping the breaker. So yeah, the crook was mining Bitcoin on someone else's dime. Anyway, this one here dead. We have to think power supply problem on this one. There are a couple of capacitors in these power supplies. Oh, I see lots of discoloration down here. There's been a lot of heat in this power supply, but there are capacitors in this particular machine that do give us lots of issues down in here. Usually these ones down here. I have to remove the board to get to it. And this should be, I think, a relatively straightforward repair. I've done a few of these. I've got a machine like this. You guys have seen it. Bought it for $24.95. And I don't think I've even used it once since I got it. I used to do a lot of international conversions back in the day, but of course these days nobody's trading tapes on VHS. But back in the day we certainly did a few. Pop out the screws, unplug the connectors here, and maybe forget, is there screws on the bottom? There's a couple of screws on the bottom on this that I have to undo. Yeah, there's 2 of them down here. And then that chassis should lift up, or maybe even the entire board will lift out with the chassis attached. It's been a while since I've been into one of these ones, so yeah. Chassis lifts out, undo that plug. Chassis lifts out, we'll do the mode switch while I'm in here, which is right there. Now I need to lift out the board. I gotta pull the front panel off and remove this cable over here. Undo this plug. one of the plugs. We'll do this one here. We'll do that plug. This is the converter board, if I'm not mistaken. Take the front panel off next. So for those of you guys wondering which was the better machine, this one or the Panasonic AGW1, this one, superior. The AGW1 was a piece of crap. The converter looked like junk compared to this one. Everything had a lot of motion stutter on it. It just did not look good. And the board should, I think it just lifts out now. There's just some plastic catches that hold it in place now. And it will just lift right out. And there is the board that I need to work on. Ooh, wow. Yeah, there's a fair bit of hot circuits on here. If we look down here at the board here, there's some sections of the board that have been a little bit toasty. Right, zener diode there is toasty. I wonder if it's shot. And some more over here. Or down here. That's toasty over here. That was actually let go completely. I wonder if it's shot. Just test it with a meter and see if the diode is still okay. We'll resolder that first, and we'll check the ESR on a couple of these caps over here. These ones are the ones that usually cause trouble, but who knows what's happened on this one, because it looks like this has been very, very warm. You can see how hot it's gotten. Look at that board is all scorched here. That resistor there looks like it could be open. It's certainly come off the board. I'm going to loosen this. The solder is let go completely on there. This is a zener diode. So the voltage may have gone a little bit hot on this thing when the caps failed or something. She's gotten hot, that's for sure. Looks like the trace might be damaged here as well. We'll just reflow the solder on here. Start there. I'm going to pull the zener out and just check it. It might be bad. I don't know what voltage it is either. Hopefully it's not damaged to the point where we can't read what the value is. But I'll take the zener out now. Or at least disconnect one wire from it so that I can get a reading on it. Oh yeah, it looks like it might be shorted. I got conductivity both directions, so the zener is probably no bloody good. There it is. Yeah, 0.1 in that direction and 0.1 in the other direction. That zener is shorted. That's one problem. Looks like this resistor here that also got hot is open. Yeah, that resistor is open. This transistor is next to it is okay. This transistor here is, where are we here? That transistor is okay. This diode is okay. That resistor is open. That zener is shorted. I don't know what value it is. I wonder if there's a number on it that I can see. Okay, from the looks of things, that zener is part of a crowbar. I'm just tracing where the leads go and they come back here and they end up back in the power supply. So this is a crowbar protection. So the power supply voltage went too high and popped that zener. We'll see if we can figure out what power supply it was fed off of. It's probably like a 12 volt or 15 volt or something that protects circuitry in the event that the power supply goes too high, which it did in this case. So we're going to deal with the problem with the power supply first, and maybe we can bring this thing up slowly and see what the voltage rises up on here to, and try to determine what value it is. There's no markings on it. I'll try looking it up and see if I can search that, search the part number for the model and come up with a voltage. But I don't have a schematic for it, so trying to find the value of that thing is going to be very difficult. There's another cracked connection over here. You can see on this resistor. You can see that one. Another cracked connection there. It's gotten hot. This thing's had a lot of heat in it. And that's what happens with these power supplies when they start to crap out. Been more heat here. Connection there was hot. Let's check the ESR on the two caps that always go bad. I've already unsoldered them and zeroed out my meter. 25, a little bit high. And this one here is, I was measuring 2.6, but am I getting a good connection or am I still connected to the board? I was measuring 2.6, but for power supply cap, I think it's a little high. It should be like a lot lower than that. Let's just pull these out and see what the value of them is. I forget offhand. This one is a 47 at 50 volts. 47 at 50 volts should be about 0.56. Between 0.56 and 0.68. We're at 2.9. Bad. And the other one, well, we already measured that as bad anyway, but we'll yank it out of here. This is a 10 microfarad at 100 volts. This one. Pretty sure I've got one of those. I better have one of those. A 10 at 100 volts though would be, 3 ohms would be considered to be pretty good. And this one here is measuring at 29. So we got two bad ones here. Let's just source those, and we'll start with those two. Got the two new caps here, a 10 at 100 and a 47 at 63. And one goes in one way and one goes in the other. So they're kind of one's backwards compared to the way that all the other ones are facing. So you gotta be careful with the polarity, because incorrect polarity will cause a smoky situation. And it's not good when your VCR smokes. That one there. And the other one goes in the other direction here. Alright. Solder these in place, and then we're going to bring the power supply up and just monitor what it does. I'll bring it up slowly on a variac and watch what the voltage does. Make sure that we've got regulation. Make sure we've got oscillation first of all, and that we've got regulation. These two caps here are the ones that always fail on this particular model. Other ones certainly can fail as well, and we will check them. But these two here are the ones that have repeatedly failed over and over again. In fact, every one of these machines that I've seen that has been dead has been due to those caps failing. So I looked up the service manual. It's ZD1P06. That's the one that's burnt up here. Where is it here? ZD1P06. And it's showing this as a, if I'm reading this right, 11.44 to 12.03 zener diode, 12 volt zener. I should have a 12 volt zener kicking around here. We'll pop the 12 volt zener in and then see if this thing powers up. Hopefully there's nothing else that's bad. It's just that. I'll check the ESR on these other caps too, but we gotta change that zener. So I gotta go see what I've got. I should have a 12 volt just kicking around here somewhere. I didn't, so I had to make a trip into RP Electronics on their last day that the store was open to the public. So I was probably the last customer that they had. Raced in there to get some parts to fix this up today. Okay, this burnt up resistor is open. It's a 10K, and it's open. So we'll replace that as well. I got the privilege of being one of the last, if not the last customer in at RP Electronics on their last day to pick up zener diodes that I needed for this and some future work that I'm sure I will need them for. Just saves me a trip to the big city, because there's still one parts shop remaining, but it's in the big city. And even though it probably doesn't take any longer to get there, I guess it does. It's a little further out, but it's just going to the big city. Don't like having to go to the big city and deal with parking, because there's never any parking around at the place. Got a 10K resistor here to replace the one that completely was incinerated when this power supply went bad and the zener diode shorted. The crowbar shorted. Hopefully there's no other damage other than these 4 parts. Yeah, be careful with the trace on the other side because the trace is not in very good shape. It's lifting, so I may have to do some repair work on the trace. Okay, I think I got it in properly through the right pads on the traces. I'm going to get my big magnifiers on here so I can see what I'm doing because it's getting pretty small down here. Yeah, I think I got it. Measure to make sure that the traces are going where I expect them to go, because it's hard to see, but one connects here, the zener diode connects down to here, to that side of the resistor, and then this side of the resistor connects down to this transistor, and then this connects over to here. Okay, so those parts have been replaced. I guess at this point I can probably power the unit up, put the chassis on, and plug in the time display and see. We'll measure this other cap back here as well while I'm at it. I doubt that there's a problem with it, but we'll check it while I'm here. This cap shouldn't be problematic. It's not in the power supply or anything, so it shouldn't be bad, but we'll test it just for the hell of it and see what it measures. What size is it? It is a what is this thing? 1 microfarad, I think. Yeah, 1 microfarad. 1 microfarad by 50 volts. So yeah, it's 8. I mean, a good one would be like 16, between 14 and 16. So 8. That's fine. There's nothing wrong with that one. And I will test a couple of the other ones in the power supply while I'm at it, just to make sure that they're okay. Another one here that looks a little bit high in terms of ESR. We're going to pull this one out and just and check it. Which one was it again? I think it's this one right here. This is a 1010 volts, and this one is measuring open, open. There's the probe shorted. 1010 volts. That one's open. We'll check it with this little cap tester and see what it tells me, what it reads. Because we already know it's open with this one. What does this one tell me? 473 ohms. It's only measuring 4 microfarads. There you go. It's at 474 ohms. And it's supposed to be 1,000. Open. Of course, a new one. Yeah, I'm bleeding. I stabbed myself. Okay, 1,000 ohms, 1 ohm, less than 1 ohm, 0.1 ohm. That looks a little better. 1,000 at 10 volts should be like 0.12, and this is 0.1, so we're good. That one's good. Yeah, this little meter is actually kind of nice. I like it. It's for a quick test, it gets the job done. We'll be sure to put it in backwards for maximum smoke. If you're keeping count, 3 capacitors, a zener, and a resistor so far. Got another one here right there, 330 at 25 volts. It's measuring 158 and 3 ohms resistance, so this one's also bad. So 330 at 25 volts. Here's another one that's bad. This one's measuring low capacitance. Look on the fluke. The fluke's telling me it's supposed to be 470. Measuring around 215. ESR meter, the old ESR meter, .29 ohms, bad. New capacitor tester, 35 ohms, only showing 52 microfarads on this one. 35 microfarads, this one's bad. This is a 470 at 10. This thing's full of bad caps. I better check some of the ones on the input side as well. Maybe something went open here. This went into an over voltage is what happened and blew a bunch of stuff out. 470 at 10. Good thing I got a stocked up parts. I should have some 470s. I'm going to be running out of caps at the rate I'm going now. I have another 470 at 10 that's bad. This one right here. Like they're all bad. If I take a look at this one here, make sure it's discharged, and put the meter on this one, 139 microfarads, 1.17 ohms. It's supposed to be 470 at 10 volts. So it's like this did a good job. This did a really good job of blowing up, but good. Most of these ones I have seen, and I've seen a few of them, you know, it's just got the 2 caps here in the power supply and here, those 2 that go bad. Every other one that I've seen, it's only been those 2 that have been bad, and everything else has been fine. But this one here, they're all bad. But I mean, this one had a lot of, look at all the blackness on the board here, right? It's been hot. I don't know, maybe it sat running 24 hours a day. Never turned off, or it sat in a hot cabinet or something, right? But certainly she was run pretty warm. Okay, I'm going to power this unit up. I'm powering it up at around 80 volts on the Variac. I want to see whether, make sure nothing's touching underneath here first of all. I want to see whether I get a VFD display light up. I'm just going to power it up momentarily. And I see a light flash there. Power light flash, it's on. VFD is not lighting up. Might need a little bit more voltage, but the set's powering up. You see the lights come on the front here? We have power. The display is very dim, but that's a good sign. It didn't blow up. So I'm going to put the unit back in the chassis, and we will attempt to power this unit up and see if it's fixed. At least we know the power supply starts and nothing blew up. I didn't see any smoke. I wouldn't expect to see any, but knowing how these power supplies can sometimes go kind of screwy, especially when they're in the state that this one was in, which is in a pretty bad state with all those parts that had failed in it. You just never know what's going to happen, right? So set the chassis back in. There is a process for this. Got to go in the right way. I've seen people break boards by not putting them in right because there's keyways that have to line up. So you've got to kind of be careful when setting these boards in place. Yeah, I believe the board's in place now. We'll plug in the connectors. And I'm going to clean this mode switch while I'm in here. It should just pop off. Because you know it needs to be cleaned. They always need to be cleaned. So this is Deox at D100 that I'm using, which is the pure cleanser without any propellant in it. As you can see, it got a fair bit of dirt off of that switch. We'll put a little more on the contacts here. Put some in here just to protect it. And I'll put some on the contacts here. And then we'll wipe these and see if what dirt comes off these ones. A little bit. Okay, time to reinstall the mechanism. Belt's okay. Get these connectors out of the way and just drop the mechanism in place. And it should just pop in, which it does. You can redo the connectors, put a couple screws in it to hold it in place, and then we can test it and see whether I succeeded in fixing this one. I'm sure I have, I just won't know until I actually get it powered up. Another one over here that'll hold the chassis in place. Next is the circuit board in the front, and then I can try powering the unit up and see what happens. Alright, I'll try powering the unit up now. Let's see whether it turns on or whether it goes kaboom. That turns on. The vacuum display is not lighting up. Or if it is, it's very dim. I'm not so sure I'm too worried about that. If that's all that's not working is the display. I'll have to talk to the guy and see. I want to make sure this thing works. If it works, I'll talk to him. If he wants to go further to fix the display, then we may have to proceed. But I'm already probably pretty close to the limit that I kind of gave him an idea what he's going to be looking at. And with all the parts I put in it right now, I'm there. I'm probably over there because I had to make a special trip into Burnaby to get the zener diode. So we'll see if it plays. If it does, I'm going to talk to the guy and see if he's concerned about the display. If he's not, then I'm going to forget the display, because it's really not necessary. Nobody's setting this up as a, like, nobody's using one of these machines and setting timers. And if you are, you're using the on-screen display anyway. So first I'm going to install a PAL tape, and we'll see if it converts it to NTSC. Right now it's in through mode. Where's the buttons here? Play. And of course it's outputting PAL, but if I switch it to NTSC, bink, NTSC. There we go. This is a PAL tape that I'm playing now. Complete with the warning, because the Wiggles will file a copyright strike if I play more than about 5 seconds of their video. But this is a PAL tape outputting in NTSC. So the machine works. And I'll put a CCAM tape in next. See, if I turn the converter off, we're going to look at a PAL signal, because this TV does not convert PAL, or does not play PAL, I should say. So that's working. We'll stop this, and I'll try a CCAM tape. Okay, this next tape is CCAM. It's French. Obviously it's French, it's CCAM, but I mean it's in French. There it is, playing a French CCAM tape. So this is working. I'm just going to give the owner of this a quick call and ask him whether he cares that the front display, the time display, doesn't work. I doubt that he's going to care about that, but I gotta talk to him. So I guess I'll make that call, and we'll see whether I'm going to dig into this further for the display. But I think it's probably highly unlikely he's going to be concerned about the display, because everything can be displayed on the screen. So as I fully suspected, just had a nice conversation with the owner of the unit, and he says, the display, no, I don't care about the display. All I care is that the machine works, so we're throwing it together, no display. So the unit's all back together and operational. I'm just playing one of my test tape here, NTSC test tape. Everything's looking good. As I say, I talked to the fellow that owns it, and he doesn't care about the display, which I didn't expect that he would. There's all the parts that I had to change in there. We had a total of, 6 capacitors? 6 capacitors, 1 zener diode, and 1 annihilated resistor. All because either A cap went bad, or B, a connection broke. Probably both. Cap went bad, got hot, connection broke, regulation was lost, and of course these things, we don't call them voltage to smoke converters for nothing, because yeah, they have a tendency to blow up but good sometimes. A spaceship just pulled up out in front of my house. Actually, a spaceship just made a U-turn in my driveway. At least it wasn't a Tesla, or I'd be throwing rocks at them. Forward search, reverse search, this shot that's coming up on here, pretty windy that day. And yes, that is time lapse. But it was time lapse from a tape or a video, not from stills. Nice dropouts on my tape. Tape's got lots of damage. This was shot on a 4K camera at 30 frames, but it was sped up to time lapse. shot on a AX100 the last time I was down in the States. That's I think that's either the California or Oregon coast, one of the two. Anyway, it was a cloudy, windy day, so I got some great pictures. My clock has gone kind of screwy. Look at the date. The days are just flying past today. Anyway, thanks for watching. We'll catch you in the next one. Bye.